Mastering artificial neural networks. Early stopping prevents overfitting by stopping models from memorizing noise. When is early stopping? A technique used in artificial neural networks to halt training when a model's performance on the validation dataset starts deteriorating, effective in preventing overfitting. And how does it achieve this? By avoiding the memorization of noise in the training data and reducing the risk of the model being too complex. Early stopping is an effective technique used in artificial neural networks, ANNs, to prevent overfitting by halting the training process when the model's performance on the validation dataset starts to deteriorate. This technique is particularly useful in scenarios where the model has access to a large amount of training data, and the risk of overfitting is high. When a model is trained on a dataset, it is exposed to both the underlying patterns and the noise present in the data. Initially, the model learns to fit the underlying patterns, resulting in improved performance on the training data. However, as the training progresses, the model may start to fit the noise in the data, leading to a deterioration in its performance on the validation dataset. This phenomenon is known as overfitting. Early stopping is an effective way to prevent overfitting by stopping the training process when the model's performance on the validation dataset starts to deteriorate. The key idea behind early stopping is to monitor the model's performance on the validation dataset during training and stop the training process when the performance reaches a plateau or starts to decrease. When the training process is stopped early, the model is prevented from memorizing the noise in the training data. This is because the model is not given enough time to fit the noise, and instead, it is forced to focus on learning the underlying patterns in the data. As a result, the risk of overfitting is significantly reduced, and the model becomes more generalizable to new, unseen data. The early stopping technique achieves this by avoiding the memorization of noise in the training data in several ways. 1. Regularization. Early stopping can be viewed as a form of regularization, which helps to prevent the model from becoming too complex. By stopping the training process early, the model is prevented from overfitting the training data, which reduces the risk of overcomplexity. 2. Model simplicity. Early stopping encourages the model to learn simpler representations of the data, which reduces the risk of overfitting. A simpler model is less likely to fit the noise in the data, and more likely to generalize well to new data. 3. Reduced capacity. By stopping the training process early, the model's capacity to fit the data is reduced. This reduces the risk of the model becoming too complex and overfitting the training data. 4. Improved generalization. Early stopping helps to improve the model's generalization capabilities by preventing it from memorizing the noise in the training data. As a result, the model becomes more robust and generalizable to new, unseen data. In addition to preventing overfitting, early stopping has several other benefits, including 1. Computational efficiency. Early stopping can significantly reduce the computational resources required for training, as the training process is stopped early, reducing the number of iterations and epochs required. 2. Reduced risk of overtraining. Early stopping reduces the risk of overtraining, which can occur when the model is trained for too many epochs, resulting in decreased performance on the validation dataset. 3. Improved model interpretability. Early stopping can improve the interpretability of the model by preventing it from becoming too complex, which can make it difficult to understand and interpret. In conclusion, early stopping is an effective technique used in artificial neural networks to prevent overfitting by halting the training process when the model's performance on the validation dataset starts to deteriorate. By preventing the model from memorizing the noise in the training data, early stopping reduces the risk of overfitting and improves the model's generalization capabilities, making it a valuable tool in the machine learning toolkit.